Hello everyone. In this video, we're going to show you how to profile a simulation with GPU sim. So the purpose is to show one example of ghost tooling. So for example, if we have this FIR benchmark, we first need to compile it, just a regular way to compile an FIR benchmark. This is already compiled. We can run ./FIR. With timing mode, we can set a length to be a very large number. I'm not planning to finish the whole execution, but I'm just going to run long enough time to show you how to run this profiling tool. So we set it to a very long length, then we let it run. For every benchmark we run, you will see this line is printed at the beginning of the simulation. It's 39629. So it selects a random network port, and to open this port so that you can use a web server to profile this simulation. If you do not really want to profile it, then this will be just a thread waiting there in a non-blocking way, and will not cost a lot of system resources. So here the simulation is running, and what I will do is that I will use another tab in my terminal, and this currently I'm running it on a server that is located in our university, and on the other side this is my local computer. I'm going to use one command to grab some traces from the simulation and to profile it. So we'll run go to pprof with the URL http lowfrag.ec.nu.edu, or port is 39629 /debug pprof profile. Now we want to take, for example, 10-second trace, 10-second profile. And close this code, then let's run it. Then we need to wait for 10 seconds, and the simulation will continue to run. It will not really interrupt the simulation. Now, at this time, we have this sample ready. Then we can try to use some command. For example, we can run top to see which function takes the most amount of time. Then we can also use web to open a browser window to show which function that takes the longest time. For example, we can see here this function called ticking component handle takes the longest time, and the compute unit tick takes the longest time, which is reasonable because it's running lots of instructions in the simulation. Then we see this compute unit pipeline is running, and the SIMD execute stage is running, which is pretty much emulating the instruction in this simulator. At the same time, we can run some other profiling functionalities with this pprof tool. So let's use Ctrl-D to stop it. Now we can take a heap profile. So rather than using profile, we can use heap. And similarly, we can still print web. We can still use web to show this figure. And we can see here which function allocates the most amount of data. For example, this thing called new storage unit in the MEM is allocating 47%, 48% of the whole heap space, which represents the GPU memory, and which is also reasonable. And also we can see here also takes the large amount of storage space, which is the compute units register file, which is also reasonable.